Number 1 says x plus y. Well, you'll see above it that they've given you three matrices, matrix X, matrix Y, and matrix Z. So they want you to use those three for all four of these problems. Okay, so first they want you to take matrix X and add it to matrix Y. Well, you first need to decide, can you? How do you decide that? Right, you check their dimensions. What are the dimensions of matrix X? 2 by 3. What are the dimensions of matrix Y? Can you add matrices like that? Yes. To add or subtract matrices, they have to be identical. Like their rows have to match and their columns have to match. Then all you do is add corresponding elements. You can put this in the calculator if you want, but I think with adding it's faster just to do it by hand. Okay? 5 corresponds with 0, so the first element would be 5. 2 corresponds with 5, so when you add those you get 7. 8 plus 6 is -1 plus -1. 0 plus 2. And 7 plus 7. 14. Okay, your answer will also be a 2 by 3, just like both matrices were. Adding and subtracting, they have to be identical, rows and columns, and your answer will also be that same dimensions. Is that what you got? Okay, number 2, they want you to multiply, okay? We already said the x is a 2 by 3, and they're wanting you to multiply that by another 2 by 3. Why can you not do it? Right, when you're multiplying, you have to look at these insides, the ones that are sitting side by side when you write it down. They have to match. Since they don't match, you can't multiply. It's called undefined. Okay, so on the test, you probably won't be looking for can't multiply. You'll be looking for something like undefined. All right, number 3. What does number 3 want you to do? Okay, I want you to take matrix Z and do the inverse of it, and then multiply it by Z again. Okay, so we'll need the calculator to do this one. Alright, so the first thing I need to do is type in matrix Z. How do I type in a matrix? Alpha zoom. And then it's a 2 by 2, so make sure your dimensions are set right and hit OK. Then enter your 4 elements, 0, 10, 3, and 8. Okay, to find the inverse, what do? Right, you hit this button right here that says x to the -1. Okay, but we're supposed to do z to the -1 times z again. So now times alpha zoom, I have to type in z again. 0, 10, 3, and 8. Okay, the answer is 1, 0, 0, 1. That is called the identity matrix. Anytime you take a matrix and take its inverse and then multiply it back by that same matrix, this will always be your answer. It's called the identity matrix. So like had we taken matrix X, done the inverse of it, and multiplied it by X, you would have gotten back the identity matrix. Okay? Does that make sense? Now in this case, I don't know that X would have actually worked because X times X would have been a 2 by 3 times a 2 by 3, right? And so you wouldn't have been able to multiply those at all. But had it been a matrix that could have been multiplied by itself, like a 2 by 2 or a 3 by 3, or so pretty much it's got to be square, right? To multiply it by itself, you'll always get the identity matrix. All right, number 4. What is number 4 wanting you to do? Right. You multiply matrix X, which is this matrix, by 2. When you do that, what will the 5 become? 10. What will the 2 become? 4. What will 8 become? -1 will become -2, right? -1 times +2 is -2. 0 will become 0, and 7 will become 14. Okay, then you have to take matrix Y and multiply it by 3. So this will become, this will become, this will become, this will become, This 2 will become, and this 7 will become 21. Okay, and now all we have to do is add the matrices. And we already know we can add x and y because we did it over here. They're both 2 by 3s. So when we add them, our answer will also be a 2 by 3. What will the first element be? Okay, the second one? The third one? Okay, down here? Right. Okay, pretty easy. That's something I would also do by hand. You can type it in if you want. You would just type in 2, alpha zoom, put in your matrix x, plus 3, alpha zoom, put in your matrix y. Okay? All right, number 5. What are they wanting you to do in problem number 5? Does anybody remember what that negative 3 is called? A scalar. This is scalar multiplication. Does multiplying a matrix by a scalar change its dimensions? No. It's still going to be a 2 by 1. What's the special name for that type of matrix? A column matrix, because it has one column. But all you do is multiply each element by negative 3. So this would become? Negative 30. And this would become? 0. Right, and that's all. Okay, number 6. Same thing, but this time our scalar is 1/2. Multiplying by a scalar does not change the dimensions. We're still going to be left with 2 rows, 3 columns. It's just that each element is going to be half. So what's half of 1? 1/2, or you may see a 0.5, I'm not sure. What's half of 4? What's half of negative 8? Half of negative 10? Half of 2? Half of 0? 0. And there's your answer. Okay, number 7. What is number 7 wanting you to do? Multiply. How do you know if you can multiply? Right, you check the dimensions. This first matrix is a, what's the special name for that matrix? Square matrix. Anytime the rows and columns are identical, it's square. What are the dimensions of this matrix? So can you multiply them? Yes, those insides match up, so you can multiply them. What did the outsides tell you? Right, it lets us know our answer is going to have 2 rows and 1 column. Now, we learned how to multiply by hand, but let's just put it in the calculator. Okay, so I first have to enter this first matrix. So alpha zoom, it's a 2 by 2. And its elements are negative 6, 3, 2, and negative 5. Okay, and then I multiply it by another matrix with the dimensions 2 by 1, so I have to go up here and change that. And you'll know, like when you're doing a problem, if you've entered the dimensions wrong, because it won't look like the matrix on your paper. Like had this popped up sideways, I would have known I entered it wrong. But it pops up and looks just like this. So I enter 1 on top, 3 on bottom, and then I can hit equals, and my answer is 3, negative 13. Okay, what does number 8 want you to do? Subtract. What did I teach you when I was talking about subtracting matrices? Well, first of all, can these be subtracted? Yes, because both of them are what? They're identical. They're both 1 by 2s. What's the special name for that type of matrix? A row matrix, because they have 1 row. Since they're both 1 by 2s, our answer will also be a 1 by 2. And you can subtract like 3 minus 10, 0 minus negative 4. But some students find it easier to just go ahead and change it to addition. But to be able to do that, what do you have to do? Change the signs that came after the sign you changed. So 10 would become negative 10, 4 would become positive 4. Really, it's up to you. Okay? 3 plus a negative 10 is negative 7. And isn't that what we have gotten had we kept it 3 minus 10? 0 minus 4 is negative 4 though. Sorry, I was looking at that minus the 10. 0 plus 4 is positive 4. And that's what we would have had we just not messed with the signs. We would have ended up with a 0 minus a negative 4. Well, 0 minus a negative 4 becomes plus, which is why it's positive. Okay, so whatever you're more comfortable with. If you need to change it to addition, just remember to change every sign after it. If you're fine with subtracting negatives, go for it. Okay, number 9. What is number 9 wanting you to do? Add them. Can they be added? No, why not?
Because it's undefined.
It is undefined because this one is a 1 by 3. Remember, it's a row matrix, and this one is a 3 by 2. So you can't add them, or you couldn't subtract them. Could you have multiplied them? Yes. You could have multiplied these and you would have got a 1 by 2 as your answer. But you can't add them, so it's undefined. Okay, number 10 is just like the problem we just did, number 7. It's a 2 by 2 times a 2 by 1. So yes, we can multiply because the insides match up, and our answer is going to be a 2 by 1. Remember when you're doing stuff like this on the test, we just did a 2 by 2 times a 2 by 1. So if you don't want to like retype it all in, you can just use the up arrow and highlight it, and when you hit enter, it kind of copies and pastes it. And then you can just go through and change the elements to the new elements they need to be. But that's completely up to you. You can type it all in if you feel more comfortable, or you can copy and paste and cover. Just make sure if you are copy and pasting and covering that you really check to make sure you covered everything correctly. Like look at it, 5, 5, 5, 5, 1, 6. And you get 35, 35. Okay, next page. Evaluate the determinant. Okay, when I was looking at the test myself, I noticed that they don't come right out and say evaluate the determinant. What you'll see is something like this. They'll name the matrix. Remember, you can name a matrix with any capital letter. So like we'll just call this matrix A. And then they might say something like evaluate, and then they'll have this. Those bars that look like absolute value bars let you know to take the determinant. Okay, so remember that. If they give you a matrix and then they put absolute value looking bars around the matrix, they're letting you know to do the determinant. Okay, another way I saw this written was, I mean, you would have figured this one out, but they put evaluate, determinant, well, DET of A. That's another way I saw it. Okay, so just make sure you know that both of those statements mean find the determinant of matrix A. Now, we learned the determinant by hand. Remember, it was A times D, which is this one times this one, minus B times C, this one times this one. But minus is part of the formula, and what does B times C give us? So what happens right here? And so our determinant is 41. But you don't have to remember how to do this formula. You don't have to remember how to do the determinant by hand, because the calculator will do it for you if you can remember how to type in determinant. Does anybody remember how to type in determinant? Right. Second matrix. Go over to math. There it is. Once you have done that, you just type in your determinant using alpha zoom. It's a 2 by 2. Okay, which in my opinion takes longer than by hand, but if you're not completely comfortable with the formula, you better type it in. Okay, and then enter and see how we got 41 also. So it's up to you. If you can remember A times D minus B times C, that's fine. If not, do it on the calculator.
So how do you
We didn't learn that, so you would need the calculator. Okay, let's look at number 12. It's another 2 by 2 that they want the determinant of. Well, we just did one, so I'm just going to copy and paste and cover up those elements with the new elements. So let's see, we got a -5 down here in the bottom right, and then a -2, and then a +9, and then a 0. So just make sure you look at them and cover them all correctly. 0, 9, -2, -5. And so the answer is gross. Okay. Okay, so the determinant of this matrix is 18. And remember, that's what we would have got. 0 times -5 is 0, minus 9 times -2 is -18. A negative and a negative make a positive, so +18. Okay? Now, we did not learn how to do the determinant of a 3 by 3 by hand, so we'll definitely need the calculator for these. So, you do it the same way. Second matrix determinant is under math, but this time, alpha zoom, set up a 3 by 3. Okay, and then enter the 9 elements. So 0, -4, 10, 2, -3, 5, negative 1, 7, and 8. And always check your elements, because one little mistake will mess up the whole thing. 0, negative 4, 10, 2, negative 3, 5, negative 1, 7, 8, and we're doing the determinant of it. 194. Yes? What do you mean? I don't know. I've never tried that. You could try it and see if you still get a 194, but I've never tried that. Okay, I don't want to waste time doing another one just like it. What did y'all get when you took the determinant of 14? 384. Okay. Number 15, find the inverse of the following. I also showed you really quickly how to do the inverse by hand, but don't just use the calculator. Okay, you're going to type in this 2 by 2. So alpha zoom, change your dimensions to 2 by 2. Okay, the elements are 11, negative 5, oops, and then 2, negative 1. And how is it that we do the inverse with the calculator? Right, you just hit this x to the negative 1 and then hit enter, and it does all the work for you. There's the inverse. 1, negative 5, 2, negative 11. Now, I don't want you to assume that that's all that happens when you do the inverse is the numbers switch around their location. I will show you quickly why that occurred with this particular matrix. I don't know if you remember, but by hand, the formula for the inverse, this is what all the calculator is doing for you. When you hit that little negative 1 button, the calculator is going to do all this. It's going to take the A and the D and flip-flop them. It's going to take the B and the C and keep them where they are, but change their sign. So if I do that with this matrix, 1 over the determinant would be negative 11 minus negative 10. So negative 11 plus 10 is negative 1. Then it would switch around the A and the D. So negative 1 would come up here, and 11 would go down there. 5 would become positive. 2 would become negative. Isn't 1 over negative 1 just basically negative 1? So negative 1 times negative 1 is positive 1. Negative 1 times 5 is negative 5. Negative 1 times negative 2 is positive 2, and negative 1 times 11 is negative 11. So the reason your numbers didn't really change much other than maybe a sign and location is because we ended up multiplying by negative 1. Does multiplying by 1 do much to a number? No. The only thing that really affected it was that it was a negative 1. Okay? That won't happen in most of these. Okay? Because most of the time your determinant is not 1 or negative 1. But that's why it happened here. So let's look at number 16. So alpha zoom is another 2 by 2. 1, negative 1, negative 6, and negative 3. Remember, all you have to do to find the inverse is type it in and then raise it to the negative 1. Your calculator does all the work for you. Now, say that you look at your test choices, your A, B, C, and D, and none of them look like that. They're all fraction. How can we change this to fraction? Math, and then fraction, so enter, enter. Okay, so it's 1/3, negative 1/9, and then negative 2/3, and was it negative 1/9 again? Okay, so see how that one, the inverse, ended up being totally different numbers in the original matrix? The only reason it worked out looking so nice in the first one was because our determinant was a negative 1. Alright, number 17. Another inverse of a 2 by 2. So, alpha zoom, 2 by 2. The elements are negative 1, 7, negative 1, and 7. Okay, we want to find the inverse of it, so all we have to do is raise it to the negative 1. But what's it say? It says air singular matrix. You need to know that word. There's no inverse, right? And they called it singular. Why is there no inverse? Does anybody remember what would cause a matrix to have no inverse? When what zero? The determinant equals 0. Look, if I quickly do the determinant of this by hand, A times B would give me a negative 7, minus B times C would give me a negative 7. Those become a plus. That cancels out to 0. The reason the calculator did not give you an inverse when you tried to find it is because the determinant equals 0. That's known as a singular matrix. This is all very important. You need to know all of that. If you're trying to calculate the inverse of any matrix and it won't give you one, that's because the determinant was 0, so therefore it's singular. Okay, so 18 is going to present the same problem because look at the determinant by hand. 0 times 4 is 0, minus 0 times negative 6 is 0. Aren't we going to end up with a determinant of 0? Which means what will happen when you try to do the inverse of it? No inverse, so what's that called? Singular. Okay, number 19. Solve each system using matrices. Alright, well, it says solve, and there's x's and y's. So we obviously want to know what x equals and what y equals. Does anybody remember what we have to do here? Okay, what do we do? Right, we're going to make two matrices. The first one's going to be a 2 by 2. It's going to hold all of your coefficients. Remember, coefficients are the numbers with the variables, like 4, negative 5, negative 3, and 4. Just always make sure your numbers line up. Like 4 and negative 3 are both coefficients of the x variable, so they need to be in the same column. Same thing as negative 5 and 4. You also set up a matrix with your constant values. Negative 13 and negative 10. Now to actually solve and figure out what x and y equal, what do we do with these two matrices? Right? You do the inverse of the first one and you multiply it by the second one. Okay, so let's type that in and see what we get. Anytime you're on a screen you want to get out of, if you just hit second and then mode, because really you're using the quit above it, it goes back to your main screen. Okay, so alpha zoom, we got a 2 by 2. With elements 4, negative 5, negative 3, and positive 4. We have to take the inverse of it. Don't forget that. If you just straight up multiply them and don't do the inverse, it'll be wrong. You have to do the inverse of the coefficient matrix. And then multiply it by the constant matrix, which is a 2 by 1. And its elements are negative 13 and negative 10. Okay? And then it gives you a matrix, negative 102 and negative what? 79. That means your x value is negative 102, your y value is negative 79. Now keep in mind that you're only going to have to do 10 questions a day, which is not a lot. You need to take the time to check these. Like I'm going to type in 4 times x, which we're saying is negative 102. So 4 times negative 102. Minus 5 times y, which we're saying is negative 79. And it should equal what? Negative 13. And then, of course, if you have time, check it with the second one just to make sure. And guys, with multiple choice, say that you completely forgot how to work this problem. Couldn't you just go through A, B, C, and D's choices, plug them in, see which ones worked in the system? Yes. Okay, number 20, it's the same type of problem. It's just that you have 3 variables to solve for. So our matrix is going to be a what? Our first matrix is going to be a 3 by 3. And our second matrix is going to be a 3 by 1, a column matrix. Okay, what are the elements going to be in this first row?
1, negative 1.
Right?
3, 0, 1.
Right. Why is there a 0 there?
Because.
Right, we're missing a y value here, so it was plus 0y, and then plus 1z. Okay, and then the last row?
5, 0, negative 2.
Right, just always make sure they're lined up, like all the values with x need to be in a column, your coefficients of y need to be in a column, and z. And then what elements go over here?
3, negative 5, 5.
Okay, and then to solve for x, y, and z, what do? The inverse of this one times this one, and then that takes some time, so did you already do it? Okay, what did you get for x?
Negative 1, 3,
Y?
3.
And z? Negative 2? Okay, I'll quickly check it in just the top equation. 2 times x would be 2 times negative 1. Negative 2. Plus y, we were saying, is 3. minus z. Well, minus a negative 2 would become a positive 2, correct? Well, look, doesn't the negative 2 and the positive 2 cancel each other out, leaving just 3 equals 3? Is that a true statement? So that means our numbers work. And of course, if you have time, try them with the other ones just to confirm. Okay, next page. How many edges are represented by the following adjacency matrix? Okay, does anybody remember how to figure out how many edges there would be when you're just given the matrix of the vertex edge graph? Add them all up, and keep in mind, sometimes there might be a 2. Remember that one we did the other day who had 2 connections? So you're basically just adding up every element. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 ones, or 12 numbers total. Why is it that we divide it by 2? They're being counted twice. Like, if you have A and C, those 2 vertices, and they have a connection, AC has been counted here, but then you account for it down here also. Well, isn't A to C only one edge? But in the matrix, it gets accounted for in 2 different places. That's why you have to divide your total by 2 to figure out that there's 6 edges in this vertex edge graph. Okay, now what they want us to do is to take that matrix and draw a vertex edge graph. So I'm just going to first put 5 vertices, and then it doesn't matter where you put the letters, because you won't be drawing this, like it'll be a picture and you choose the right one. Okay, so now we just have to make the appropriate connections. So A needs to connect to what? C, D, and E, correct? So I need to make a connection from A to C, A to D, and A to E. Okay, B needs to connect to C and E. So B connects to C, B connects to E. C connects to A, B, and D. So A, B, I only need to do D. And then D connects to A, which we've already done. D connects to C is already done. E connects to A is already done. E connects to B is already done. So that's it. Now, we could go back and check. There are 1, 2, 3, 4, 5, 6 edges. So we know now that we did that right. Any questions? Yes. You won't actually hand draw one because the test is on a computer. More than likely with this type of question, it would just have 4 different pictures and you pick the right one. Well, with this kind of example, they might give you a vertex edge graph with 6 edges, and then choice B might have 5 edges. And then you might have 2 choices that have 6 edges, but you got to make sure the right connections have been made in there. Like if, say that E to D had been connected here, we know that's wrong because with E to D there's a 0. So there should be no connection. So if you have a graph that has 6 edges, but then you have one of them that's connected that shouldn't be according to the matrix, you know that's not the right one. Does that make more sense? Okay, number 23. Find the area of a triangle with the vertices 3, 4, 5, 9, and -1, -4. Okay, we just learned this yesterday. This is your 3 points, so x1, y1, x2, y2, and x3, y3. Okay, there's 3 vertices because it's a triangle. Who remembers the formula for the area of a triangle using a matrix? Times what? Well, that's the geometric formula, 1/2 base times height. But with matrix, what do we have to do? The determinant, and then you just type in the matrix. Now, right, and you put a plus or minus, but in the end, area is always what? Positive. So even if your calculator spits out a negative answer, make it positive. Now, even though we only have 6 numbers, we make it a 3 by 3. Okay? You put 3, 4, and then 5, 9, and then -1, -4. So what do we fill this last column with? Ones. Okay, just remember triangles has 3 sides, so make it 3 by 3. Now you just type it in. So how do I type in 1/2? Alpha y equals, and then that's numerator over denominator. Okay, and then you should know by now how to pull up determinant. How do we do that?
Math.
Second matrix, right, math, and then there's determinant. And then we just type in this 3 by 3. So alpha zoom, make it a 3 by 3. And then you just type in those 9 elements. So 3, 4, 1, and then 5, 9, 1, and then negative 1, negative 4, 1. Okay, that's all you do. You don't have to close parentheses. And then, so your area is 2. That's all you do. The main thing you got to remember is this formula. 1/2 times the determinant of the 3 by 3 matrix. And this row has ones. Now, do you think we would have got the same answer had we put like 5, 9, 1, 3, 4, 1, negative 1, negative 4, 1? It don't matter what order you put your vertices in, as long as the 3's beside the 4, because that's the first point, 5's beside 9, and negative 1's beside negative 4. But we could have ordered them in any order. Because think about it, when you're looking at it on a graph, do you think every time that y'all picked the 3 vertices and all put them in the same order? No, you probably did on this because they were listed in a sentence. So you probably put that one first, that one second, that one third. But when you're looking at a graph with a triangle plotted, you might not all have picked the same first one. Okay, number 24. Jennifer, Natalie, and Tanya are selling pies for a school fundraiser. Customers can buy cherry pies, lemon meringue pies, and apple pies. So what do you think our variable should be? C, L, and A. Okay, now look, we have Jennifer, Natalie, and Tanya. So that's 3 equations. So I'm going to write those variables 3 times. Okay, and then you just make your equation. Jennifer sold 10 cherry plus 5 lemon plus 4 apple, and her total was $2.51. Natalie sold 5 cherry, 5 lemon, and 8 apple, and her total was $1.88. And then Tanya sold 3 cherry, be careful here, 6 apple. So what goes here? 0 lemon meringue, and then 6 apple, and her total was $1.26. So now we actually want to know, find the cost of each pie. So we want to know how much was the cherry pie, how much was lemon meringue, and how much was apple. How do we solve that problem? Right, you have to make a matrix. So 10, 5, 4, 5, 5, 8, 3, 0, 6. What are you going to do to that matrix? The inverse of it. Anytime you're trying to solve for unknown variables, you always do the coefficient matrix inverse times the constant matrix. Okay, so y'all be typing that in because I'm not going to. It'll take too long. Now, I'm going to go and warn you, your answer is not going to make common sense. It was a poorly made problem. Yeah. Okay, how much was a cherry pie? $21. Okay, how much was lemon meringue? So it must have been so bad they paid people to eat it. And how much was apple? Okay, so like $10.50. You can at least check those values if you're unsure if you did it right with like maybe the top equation. So 10 times the cost of a cherry, 21, plus 5 times the cost of a lemon meringue, negative 0.2, and then plus 4 times the cost of an apple, 10.5. And then you do get 251, so that means even though they're not very good values, for, like common sense wise, they do work. Okay, now I want to talk about a couple of other things that are important. Can you take a matrix, say we have matrix A, and it's a 2 by 2. Can you multiply it by matrix B, which is also a 2 by 2, and then if you reverse the order, will you get the same answer? No, you will not. I know that normally multiplication is what we call commutative property, and you can multiply in any order, like 3 times 2 is 6, 2 times 3 is 6. But it doesn't work that way with matrix multiplication. That will not work. Think about it too like this. Say A had been a 2 by 3, and B had been a 3 by 4. that could have been multiplied, right? Because their insides match up. But if you take that and rearrange it, now you've got a 3 by 4 times a 2 by 3. So you can't even do that. Like, you could have done this, but you wouldn't have got the same answer. They wouldn't have been equal. Okay? And this one, you wouldn't have been able to do this way. Okay? So that's one thing you need to remember, that you cannot rearrange the order of multiplication. Okay, what about this? Do you think you can do matrix A and then matrix B times C group, and it will be equal to matrix A, B group times C? You can. The important thing to look at is, look, A, B, C, A, B, C. They're in order, so you can do it. Okay, pay attention. This is important. A inverse times A equals 0. Is that true? What happens when you take a matrix and you do the inverse of it and then you multiply by that same matrix? You get the identity matrix. It wouldn't equal 0. It would equal the identity matrix. Okay? Anytime you take the inverse of a matrix and you multiply it back by that same matrix, you don't get 0. You get the identity matrix every time. Okay? Can you do A plus B and get the same answer as B plus A? Yes. Matrix can be added in any order. That's the only thing, though. Subtracted, it can't be flip-flop. Multiplied, it can't be flip-flop. But it can be switched around for adding. Okay, make sure you study